So now that we've covered a few transformations, now we're going to talk about putting them together. And putting them together means we call this a composition of transformation because composition means putting things together, right? So now we're not just going to do a translation, we're not just going to do a reflection. Now we're going to do both. And so we'll have two different transformations happening one after the other. There's one special kind, we call it a glide reflection, where we first start with a translation followed by a reflection. And so we call that specifically a glide reflection. So let's do some of these composition of transformations, and it's basically going to be the same thing. It's just going to be having to do the work twice per problem. So here it says triangle JKL has vertices, and it tells us where they are. They want us to graph the triangle and its image after a translation. So make sure you know which transformations they're asking for. In this case, first you have to do a translation and then a reflection in the y-axis. Now this right here, this is basically our rule. So I'm going to go ahead and write it out so you can understand what that means. The rule is in this case, it says for the translation, you're going to take each coordinate point and we're going to add nothing to our x values and add 4 to our y values. So this is our rule for our translation. For our reflection, remember when we have to reflect over the y-axis, we are going to take every coordinate point and we're going to change our sign for our x values and leave our y's the same. So here we have both of our rules. We're going to go ahead and apply the first one. So this is going to be my first one and this is going to be my second one. So let's go ahead and try this out. First, I'm going to apply the rule for my translation. And then I'm going to apply the rule for my reflection. So for our first point, J, which is at 6, -1, it's going to become J prime. And our rule says we have to add nothing to our x value, but we're going to add 4 to our y values. So -1 plus a 4 is going to give us a 3. And we'll continue on with this pattern for our translations for the rest of the points. Now that I have applied the rules for our translations, now I'm going to take and use these new points, these primes, and that's going to be now my points that I'm going to then reflect and apply the second rule to the reflection rule. So, for example, I'm going to start with J prime now. Instead of J, I'm going to start with the J prime, 6, 3. And I'm going to then transform it again. I'm going to reflect this point. Now it's instead of J prime, this is going to become J prime prime to show that this is the second transformation. And the rule for the reflection says I have to make my x, change the sign for my x. So in this case, it's a +6, so it's going to become a -6. And nothing changes for the y values. And we'll go ahead and apply this for the other 2 points. All right, so here we have our final, if you will, product, if you will. So now let's go ahead and graph these on Desmo so you can see visually what's going on. Okay, so here we have our original triangle, and now I'm going to do our first transformation. And so we will see our first transformation, which is the translation. So as you can see in the picture, we took our purple triangle and we slid it up a few notches. And so that's my translation. A translation, remember, is a slide. So we slid this triangle upwards, kind of like sliding, like I mentioned before. And now I'm going to show you our final product, which is the reflection. So now we're going to reflect this green triangle over the y = x line. All right, so now I have my original pre-image, which was the purple triangle. I slid it up after the translation and it became that green triangle, J prime, K prime, L prime, and then I reflected it over the y equals x line, not the y equals x line, y axis, and it became this blue triangle, J prime prime. And this is a glide reflection. All right, so it's called a composition of transformations because we did two different types of transformations. Hope this helps.